I'm covering Intro to Probability in this video. Probability is the measure of how likely something is to happen. A coin is a great example. Let's take a fair coin, and the chance of it landing on heads is 1/2, 50%. Most people know this as a fact. To figure out the probability of something like this happening, you have to take the amount of possibilities that you want to happen, or that meet your conditions, so in this case 1, the probability of it landing on heads, and divide it by the total number of possibilities, so 2. And then you have your answer, 1/2, 50%. 50% actually means 50 for each 100. Per, you can just change it to for each. And cent derives from the Latin centum. In Latin, centum means 100, so 50 for each 100. And that is why people say percent. Dice are another good example of probability. Let's say this is a standard dice, so 6 sides numbered through 1 to 6. And you want to find the probability of the dice to land on an even number. Then you would take the even numbers on this dice, 2, 4, and 6, so 3 even numbers in total, and divide by the total possibilities. So you get 3/6, which can be simplified into 1/2 or 50%. About some notation. I already talked about percent, but another thing I want to talk about is the way you write the probability of something. So P of T means that in the context of the coin, so in the coin flip, P of T equals the probability that the coin will land on tails, T for tails. So P of T equals 50%. And same with heads. So to find the probability of multiple flips or rolls of the dice, we'll do coin flips in this case. If you just write them out like I have here, you get HH, TT, heads, heads, tails, tails, HT, heads, tails, tails, heads, and so you have 4, and so that means that you have 1/4 is the outcome of happening heads, heads, or heads, tails, but it's also 25%. But another way to find this out is by having sort of an equation, which can be represented, if you want to find the number of outcomes, take x. This is like how many x equals the number of outcomes in one instance. So one flip, there's 2 outcomes total. So you do x to the f, and f is 2 in this case for the double flip, for 2 flips, and it's the number of flips in this case, or it's the number of repeats of this instant, of this thing that you're doing, a rolling of the dice, flip of the coin, drop of a ball, or whatever. And so it's x to the f, so 2 squared, 2 to the second, and that comes to 4, so 2 times 2, 4, and then I guess you divide 1 by that number, so 1/4, 25%, or you can put it into 1/x to the f, or in the 2 double flip case, 1/2 squared. For 3 flips, by writing it out, you find heads, heads, tails, heads, 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 tails, 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 etc., etc. And you find that you have a total of 1, 2, 3, 4, 5, 6, 7, 8 outcomes total. And the math for that is 2 to the third this time, not 3 squared. It's easy to get those mixed up. It's 2 to the third, because you still have 2 that x number, the x is still 2. It's still just 2 outcomes for one instance, that one thing that you do, the flip in this case, and then you do that 3 times, and so it's 1/2 times, it's 2 times 2 times 2, so that's 2 times 2 is 4, 4 times 2, 8. And when you think about this probability, you can also think of it as halving a half. So if you have you have heads and heads, and then you have heads and tails, but then you can, so 1/2, 50%, then you can have that again and get 25% or 1/4. And then with 3 flips, have 1/4 again, you get 1/8, or 12.5% chance. And that's how you find the probability of multiple instances. Let's figure out the chance of a four flips of a fair two-sided coin. So we're doing a coin for 4 flips, and you can pause the video right now if you want to figure it out by yourself, but I will do it in a second. So if we go back here, you can see that the total number of outcomes is equal to x to the f. So where x is the number of outcomes in one instance, and so like the total number of outcomes for one flip, so 2. And f in this case is 4. It's the number of flips in this case, or the number of repeats of the instance. So it would be 2 to the 4th. But wait a minute here, I have to change this to superscript. Now, that actually equals 16, because 2 times 2 equals 4. 4 times 2 equals times 2 equals 8. And then you do that one more time, equals 16. And here, look, you can see 1, 2, 3, 4 2s. And now if you want to find the chance in a fraction, in fractional form, it's 1 over x to the f. So 1 over 2/4, or 1 over 16. 1 over 16. And then you have to figure out the percentage now. I know the percentage for 1/8, and that is 12.5% chance. Whoops. For 1 over 8, the chance is 12.5% chance. And percent, when this, basically all these percents add up to 1. So 1/8, there's 8 1/8ths in 1. So they all add up to 1 whole. And when you multiply it by 100 to find if you're finding the percent, you multiply your number by 100. So then you get this bigger number, and it's the percent. So actually, 1/8 is equal to 12.125. This is how there's 8 0.125s in 1. But if you change it to a percent, it's for each 100, remember? So you have to multiply this number by 100, or you can do it in the beginning right here and turn this one into 100 over 16 instead of 1 over 16. So you multiplied that 1 by 100. So then, since we know that what 1/8 is, 1/16 is actually half of 1/8. So it would be 6.25%. And that's how many, so for any individual outcome, like heads, 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 all the way tails, heads, tails, heads, tails, these all equals, there's all a 6.25% chance for these happening. Earlier, I showed you a clip of me rolling 2 dice, and they both landed on 1. And actually, I want you to do this as a bonus problem that I will solve in front of you in my next video in this probability series. And the question is, what is the probability that two 6-sided dice both land on 1? And here, I'll show you a clip of that dicing game.